Section 3.4 is on the chain rule, quite possibly the most important rule. So I'd say the two most important rules for derivatives in calculus is first the power rule, and then second that combined with the chain rule. With those two rules, you can find the derivative of the vast majority of functions. So we're going to learn the chain rule, the actual formal definition, then we're going to extend it to call it the general power rule. We're going to learn how to simplify some of our derivatives. We're going to use our transcendental functions, which is our trig functions, log functions, and exponential functions with the chain rule. We're going to learn how to find the derivative of log functions, and then we're going to do bases other than e. So a lot to do in this section, a big section. This is really the heart of the rest of the derivative rules that we need to do. So please, please, please take your time in this section and make sure to do a lot of examples. So why do we care about the chain rules? And it says, we have seen to solve problems like the derivative with respect to x of 2x squared plus 1, or 2x plus 1 quantity squared, by expanding 2x plus 1 quantity squared. So you just FOIL it out, right? So it'd be 2x times 2x, which is 4x squared. Then you'd have plus a 2x plus 1, so that'd be plus 4x plus 1. So if it were in this form right here, you could find the derivative by expanding it, FOILing it, and then finding the derivative of it by each individual term. So we know then we could find the derivative. However, what if we wanted to find the derivative with respect to x of 2x plus 1 to the 45th power? And so the idea of expanding it, we would have to expand it 45 times, and it no longer becomes viable. It says this is not feasible for us to expand anymore. So what can we do? We use a rule called the chain rule. Really, I would like to use the general power rule, but we'll start off with the formal definition. It says if y is equal to f of u is a differentiable function of u, and u, which is equal to g of x, is a differentiable function of x, then y equals f of g of x, the compositions of functions, is differentiable function of x, and dy dx equals du dx. Now, dy dx equals dy du dx. So when you're looking at this, it's kind of like, yeah, I guess that's true, right? Because the du's would simplify and you'd be left with dy dx. But really in here, there's a lot to say. This dy du right here, this part is the derivative of the outside. And this right here, the du dx, is going to be the derivative of the inside. And you're going to see what I mean momentarily with that. But that's inherently what we're doing here, is we're finding the derivative of the outside of the function, and then we're multiplying it times the derivative of the inside of the function. And you can see that with the composition of functions. You could call g of x the inside of the function, f of x the outside of the function. Notice you do f prime of x, which would be the derivative of the outside function, keep the inside function exactly the same, and then you multiply it times the derivative of the outside function. So we're going to do exactly the chain rule for a couple examples, and then I'm just going to kind of extend it to the general power rule for you as quick as possible so you don't have to show quite as much work. So it says the chain rule uses composition of functions. We will simplify this process by using a technique called U substitution that you may have seen previously in college algebra. In all honesty, you should have seen it in intermediate algebra, college algebra, and trigonometry. U substitution, where you replace something ugly with u, do the problem now with u because it's a lot nicer, and then you back substitute for u at the end. That's essentially what we're doing. So it says define u. U is usually the inside function or the function in the parentheses. I'm going to go ahead and highlight all of this because this is very, very important. The function in the parentheses underneath the radical, etc. It says find u prime, which is du dx, right? Okay. And instead of remember, well, that's fine. I'll show you the notation. It says rewrite the original function in terms of u and differentiate. The chain rule says we must multiply the answer times u prime. Do not forget to multiply by u prime. So that's what the number one mistake is forgetting to multiply by the inside. Then it says back substitute for u and simplify if possible. So let's see some examples of this.